All right, guys, welcome to your practice test review. I'm going to be going over um, some of the practice test questions, not all of it, and then you can use that to study for your test tomorrow. All right, let's start with your practice test question number one. So, one, two, and three, you guys are going to have to know that, and then I'll post something else right next to this that you guys will have to know and that you guys will have during the test. All right, so let's start with this whole unit starts with the mole. To know what a mole is, you need to know how many atoms, molecules, formula units are in a mole. So, real quick, wrong pen. All right, there you go. All right, so 1 mole can be equal to 6.02 times 10 to the 23rd, and this is important, atoms, or I could say the word molecules. That's horrible spelling. Molecules, or I could say the word formula units. These are all going to be the same, right? So if I'm looking here in my practice test, molecules, I'm going to refer back to 6.02 times 10 to the 23rd. If it says formula units, I'm going to go back to 6.02 times 10 to the 23rd. They're all the same thing. Another thing to note is that we are going to be using, this is 1 mole conversion, or one conversion factor that we need to do this unit. But there's 2 other ones that we need to talk about. So number 2, the second one is 1 mole is equal to 22.4 liters. That's another one. This one always stays the same. This one always stays the same, right? If the problem says something about atoms, molecules, or formula units, we know we're using number 1. If the question says something about volume or liters, we know that we're going to use the second one because liters is just how much volume we have in something. And then for number 3, we have the last one. This is the only one that can change. It's the 1 mole is equal to the whatever molar mass, X, because we don't know what the compound is, of your compound. So the molar mass for H2O is, H is, weighs 1, but there's 2 of them, so that's times 2. Oxygen weighs basically 16. There's only 1 of them, so we multiply by 1, and then we just add everything up. So 2 times 1 is 2, plus 16 is 18. This is the molar mass. Sorry, 18 would be the molar mass for H2O. So I would write this as 1 mole is equal to 18 grams. So whenever you see the word grams, that means you're going to have to do the molar mass. And that depends on whatever compound I give you. If I would have given you H3O, it would have been, well, now you have 1 extra hydrogen, which just weighs 1. So 1 times 3, still 1 times 16, because oxygen weighs 16. This would have been 1 mole is equal to 19 grams, because you have that extra hydrogen. All right, so you guys are going to need to know all of those 3 things for your test. You can pull those up. You can have those out. That's not a big deal. Just pull your notes out because you're going to need to constantly refer back to them. The important part is that you know how to use them, not that you memorize what they are. Although hopefully by now you've memorized that 1 mole is 6.02 times 10 to the 23rd atoms. All right, so with that, let's go into some of the practice problems. Let's go into a simple one. We're just trying to figure out the molar mass of elements and compounds. So I'm just going to do number 7 because it's the hardest one. And if you can get number 7, you can get all of them. All right, number 7, find the molar mass. Remember, 1 mole for molar mass is equal to the total mass in grams of whatever compound is here. In this case, we're dealing with Al2, parentheses, CO3, and then 3. So we just want to get the entire weight. How do we do that? Well, we know that there's 2 aluminums, and we know that the weight, we need to go to our periodic table. I'll pull this up real quick. Aluminum, my periodic table number is 26.9. I'm just going to say 27 for right now to make it easy. 27. CO3, and this is where, and then we're going to add this to whatever this is, and this is important. CO3 is not by itself. This 3 is affecting both that 3 and that carbon by multiplying it. So if we have 1 carbon, it's really times 3. So really, we've got 3 carbons times the weight of carbon, which is 12.011. I got that from the periodic table, basically 12. Oxygen, and then we're going to add this plus oxygen, which is basically 16. But now if we have 3 of them, we need to multiply this 3 times 3, have total of 9 oxygens. So really it's 16 times 9 oxygens. And then we're going to add all this up and we're done. We have our total molar mass. So let's figure what that is. All right, I'm going to use the calculator that you guys are supposed to be using, which is in Canvas. So hit OK. I'm going to go to the side. So that's going to be, go away. All right, 2 times 27 plus 3 times 12 plus 16 times 9. That gives me that my molar mass is 234 grams. So again, 1 mole is equal to 334 grams. All right. That was one of the harder ones you might see on the test. All right, going back to the practice test. Let's do number 8. All right. So in the video it covers this, but I wanted to cover it one last time. Okay, so number 8 says find the number of moles in 25.0 grams of ammonium sulfate. Okay, so just a quick note, if you see the word mole, you know that this is going to be a one-step problem. So these are the easy ones. One step, you're done. All right. If you look at number 9, how many molecules are in 14.5 grams of carbon tetrachloride? That doesn't have the word moles. Moles and molecules are not the same thing. So you know that this is going to be a two-step problem. And we'll get to this one in just a second. I wanted number 8 first. All right. So number 8. All right. You've got how many number of moles? So really you're trying to get from, and I always do this, I'm trying to get from what it gives me, my given, to moles. So that's a one step. I can see that's an easy one step. All right, let me scroll down a bit. I remember that I have 3 options. I've got 1 mole equals 6.02 times 10 to the 23rd atoms. That's an option I can use. 2 is 1 mole is equal to 22.4 liters. And number 3 is 1 mole equals my molar mass. I don't know what it is yet, but I know my unit is grams. So I'm looking here. I have to go from grams to mole. Mole to atom doesn't help me because it wants grams to mole. Mole to liter doesn't help me either. The last one, 3 moles to whatever compound they give me, X, to grams, that's the one that's going to help me get from grams to moles. So I know that I'm going to have to use number 3 in this case. So let's start with my usual, right? I am given 25.0 grams. That's 1, 2, 3. 3 significant figures. I'll put that at the start. Always do the same thing. If I have grams up top, I'm going to have mole grams here. I'm going to put grams at the bottom so that it cancels out. I'm trying to get rid of the grams, mole up top. This will always be 1 mole, and now I just have to figure out how much is ammonium sulfate. And here it's nice and it gives it to you. Normally, I might be a little mean and I might not give it to you because you should have known how to write this down based off this already. All right, but for that, we have to basically know how to add everything up, do all that. So let's go. I'm going to scroll down and let's figure out what the mass on that is. So, okay, I've got NH4, NH4, 2, SO4. Okay, and now we just have to add everything up. All right, remember this 2 is affecting both that 4 and that nitrogen. So whatever weight you get for nitrogen, multiply by 2. Whatever weight you get for hydrogen, multiply it by 4 and then by 8. 4 times 2 is 8. So let's do that together. Let's look at the periodic table. How much is N? N is 14, but it's really multiplied by 2 because of that 2 on the outside, plus there are hydrogen I know weighs 1, but there's 4 of them, and then we have to multiply this times 2. I know that S, now this one's not being affected, so I know that S is going to be 32 basically, plus oxygen, which is 15.999. I'm going to say that's 16 basically, and then multiply that by 4, add everything up, and get an answer. So let's do it. 14 times 2 plus 14 times 2, plus 1 times 4 times 2 plus 32 plus 16 times 4 gives me 132 grams of NH4SO4, ammonium sulfate. So now that I have that number, 132, I can go back here and plug it in, 132 grams. And all that's left is just do the math. So I have 25.0 multiplied by 1 is just going to be 25, and then just divided by 132 will give me my answer. So let's do it. 25. Let's go back to the calculator. 25 divided by 132, I get an answer of 0.189. I could keep going 939, but I know that I need to have 3 significant figures. This doesn't count, so 1, 2, 3. I don't have to round up, so I can just delete that 3. And my answer is 0.189 moles. And if I want to double check, I can just check my practice test. And you'll notice the practice test has the answers right next to it. That's because I don't care about that you guys get the answer. I care that you guys know how to do the process. All right, but with that, let's move forward. This one's going to cover something important. It's how to use that calculator online. So let's do that. All right, so this is the one that gives everybody trouble because it's a 2-step, but it's really not too bad. Always remember to put your significant figures. And I'm going to leave these 3 conversion factors right here because we're probably going to need to use them again. All right, so for number 9, how many molecules are in 14.5 grams of carbon tetrachloride? Again, I was nice. I gave you the compound. You don't have to figure it out. But you could have, because carbon is 1, tetra is 4, so 4 chlorines. All right, but here we go. All right, so for number 9, how many molecules all right, 14.5 grams. Notice that this doesn't say the word mole, so automatically I know that I have to do a two-step problem. So it's going to take me a little longer. All right. And the reason for that is I'm trying to go from grams to molecules. So I'm trying to go from grams to molecules. And when I look at my three options, this gram goes to mole. It doesn't go to molecules. This one goes to liters. This one goes to atoms. None of these, I can't go directly from a gram to a molecule. But what I can do is I can go from a gram to a mole. That's my first step. Once I have my mole, I can go to a molecule or an atom. This is my two-step. So that's why it's a roundabout way, but you eventually get there. So I'll write this at the top. I can't go from grams to molecules, but I can go from gram to mole to molecules. Again, molecules and moles are not the same thing. All right. So I'm gonna scroll down for this. All right, so I'm gonna start with my given. I'm given 14.5 grams of carbon of CCl4, right? I know that I have to first, to get to molecules, I need to get to mole. So grams to mole. So I'm going to be using, I can't use the first one, the second, I'm going to be using the third one, grams to moles. So whatever the weight of this compound is, CCl4. So I have to figure out, I know that this is, the top is going to be mole, because I need to get there, and then the gram is going to be bottom, and this is going to be whatever weight CCl4 is. So we have to do that first. So let's do it. CCl4, carbon is 12, plus Cl, which is, let me look that up. Cl is 35 or 36, I can't see, let me, 35.45, so that's basically just 35. All right, so 35, well, let's go ahead and let's do the whole thing. 35.45 times 4. Let's put that in a calculator. So that's going to be 12 plus 35.45 times 4 gives me 153.8, which is basically, I'll just actually put that. I'll put that number there. 153.8. And then this is always 1 mole. All right, so let's see what that gives me. Going back here, 14.5 times 1 is just going to be the same thing. So then divide that by what we got, 153.8. I get that this is equal to 0.0 or 0.09427. I'll stop right there. Okay, but this is in moles, right? So I was finally able to get from grams to mole, but I'm not exactly where I need to be yet. Now I need to go from mole to molecule. So I've already used the third formula. The second one, moles to liter, doesn't help me get to molecules, but the first one, mole to atoms, and atoms is the same as molecules, helps me get to where I need to go. Now this is important for you guys to know how to use a calculator. All right, so let's solve this one together. So our given is 0.09427 mole. And then we have that we have mole at the bottom. And then we're going to have molecules at the top. Okay, so we know that 1 mole is equal to, we've done this a million times, 6.0 times 10 to the 23rd. So let's put this in the calculator. And I'm going to put this, I'm going to maximize this so you can see what I'm doing. All right, so you have 0.09427 multiplied by 6.02, hit this times 10, and it does the automatic to the power of 2, 3, hit execute, and there you go. Here's your answer. Now notice something, that little E at the end. So we ended up getting 5.67 times 10. That's what that E means. So when you see E22, that means times 10 to the power of 22, and then the unit, which was molecules. Okay, we have 1, 2, 3 significant figures because at the beginning we started off with 14.5, which is 1, 2, 3. All right, one last thing before we leave that I want to cover is how to put a certain calculation. For the empirical and the molecular, I'm going to leave that to you guys because that's relatively easy. I'll try to do it. We'll see if we have time. But I kind of wanted to go a problem that gives a lot of people a hard time. So going from atoms to mole. Going from, let's say if I have 2 atoms, just 2, and I want to see how many moles that is, I know I have to use my mole to atom, that's 6.02 times 10 to the 23rd again. I'll actually make this a little more complicated than 2. Let's say I have 2 times 10 to the 24th. Okay? All right, if I want to, and this is atoms. If I want to convert atoms at the top, atoms at the bottom, mole at the top, I know there's going to be 1. I know this bottom number is going to be 6.02 times 10 to the 23rd. All right, how I want you guys putting this in the calculator is as follows. All right, you know that 2 is going to be at the top. You know you're going to divide by 6.02. So when you pull up your calculator, you are going to put it in parentheses. So 2 times 10 to the 24th, hit to the right, right? Because if you don't, then the parentheses does it weird. So you don't want that. You want to hit to the right, then do parentheses. Now it's the whole thing. Now we're dividing by, this is a super important step if you want to get the answer right. I'll put parentheses again, 6.02 times 10 to the 23rd. Again, hit to the right, and then close the parentheses. Now everything looks nice and neat. You can hit execute, and you get your answer of 3.322. I don't need that many. My answer only had one significant, or my given only had one significant figure, so I'll stop at 3. And that's it. 3 moles of, I didn't give you an element, so it doesn't matter, but just your answer would have been 3 moles. And that's how you would do that. So make sure you are putting everything in parentheses just like that. If you want to, especially when you divide. When you multiply, it's not that big of a deal, but when you're dividing, the parentheses start to matter a lot more. So make sure you're putting it nice and neat like that.